Hey, Mike Panaki here with Network Protocol Specialists. And today we are going to be decoding some packets. So I'd like to welcome everyone that's on. As always, let me just scroll down here a little bit. Comments are highly welcomed. Questions, always interested to hear what you have to say. So on Twitter, @mpanok is my Twitter ID there, and so let me just get rid of that, and so that you know, as I'm going through here, I not only analyze packets, but I produce these things myself. So if you see me looking down and clicking on things, it's because I'm moving the video around. All right, before we get going into taking a look at packets, there are a couple things that I would like to talk about, and one of those is that I am going to be speaking at Interop this year. So this will be, I think, my 22nd year of teaching at Interop. And so I'd like to welcome you. I'm going to be doing a class on Tuesday, May 1st on Wireshark and digging into packets. So this will be a day-long class. So if you can make it to Interop, that would be great. Love to see you there. Even if you don't come to my class, still love to see you. And if you are going to be coming to Interop, there's a discount if you use my last name. So if you go in and sign up for Interop, you can put in the discount code PANAKI, and that will save you $300 on your pass there. So not a bad deal for being able to go in and save a few bucks on that. So feel free to use that pass if you'd like, and that will get you in a little bit cheaper. All right, so with that said, I think it's time that we go in and start taking a look at some packets here. Let me clear some things out there and make sure I got everything all set back up the way I want it here. All right, so let's get rolling with taking a look at packets. So when it comes to capturing and analyzing packets, oftentimes we see people start using a tool like Wireshark, and they get hung up on capturing the right packets, on how to start decoding those, etc. So what I like to do is periodically do a webcast, a YouTube live event like this, so that we can go in and we can talk about some of the things that we can do when it comes to doing packet capture. And one of the most important things about doing packet captures is getting the right packets. So one of the things that I'd like to take a look at before we get started with digging into the packets is taking a look at a way to get in line. So one of those ways of doing that is using a tap or a span port. So in this case, what I've done is I've taken some little Netgear switches and converted those over. And let's see if we can switch this over okay. Hey, that went all right. So right here, I have this Netgear GS105E switch. Now this is just a simple little barely manageable switch out there. But one of the things that this switch does pretty well is it allows us to go in and do port mirroring. So what I've done is I've set this thing up so that we've got our source port right here. And that source port is being mirrored over here to our analyzer port. And what that allows us to do is to go in and start taking a look at what packets are going in and out of this port. Because getting in the path of the packets is always one of the most challenging things. So typically what I'll do is I'll take and plug my network into port number 5 right here. I'll plug the device I want to monitor into port number 1. Then I'll come in here and in port number 4, which is my analyzer port, I'll plug my PC. Now these things go for about 32 bucks on Amazon. I've got a whole pile of them that I've bought over the years. You can see this one has a few scratches on it there. And I keep these in all of my bags because if I want to go out and get in line. Now we could spend a significant amount of time talking about span versus tap, reliability, etc. So some of the challenges that we run into is with this little gizmo right here, this little Netgear GS105E switch. One of the challenges is if we lose power on that power supply right there, the connection drops. So when we start talking about capturing and looking at packets, I've got a tap set up on my internet connection. Now, what we find with that internet connection is that I've got a fault-tolerant tap in there. And the reason I have a fault-tolerant tap, and let's see if we can get all of this switched back over here without it being a huge mess. And we'll flip over there. So one of the reasons that I use a fault-tolerant tap is I want to make sure that if I lose power or if the power supply fails on that tap, that it doesn't knock down my internet connection. Because it would be a real bummer if I was doing a presentation like this and all of a sudden we lost connectivity because that power supply went out. So depending on the environment you're in, using something like a Netgear switch may not do the trick. Now, when it comes to configuring that Netgear switch, if you go out here to my YouTube channel, I do have a video out there on how to go in and configure that switch to mirror ports. Now, one of the things that was really interesting that we found when we were going in and taking a look at that was that this switch reduced the throughput down to 500 megabits per second in each direction when we were running full duplex traffic. So on the good side of things, that limits the total amount of traffic to 1 gigabit per second, so I can't overrun my mirror port. On the downside, it does reduce that throughput down to 500 megabits per second. So good and bad, but certainly having a little something like this to throw in your bag when you're going out and doing troubleshooting is a great way to get your PC in the path of the packets, because just plugging into a switch port isn't going to cut that for us. Okay, so let's come over here and let's start taking a look at some packets. So we will switch over there, and here we have Wireshark. So this is where I've got Wireshark loaded on my machine. One of the things I did was I went out and I made sure that I had the latest and greatest version before we got started. So some of the things I'd like to do in our session is just take a look at some basic filters, basic things that we're going to take a look at when we're using the Wireshark analyzer. So I'm going to start out by coming in and opening a file here. And the file I'm going to open is my old .cam file. Now the .cam file is a very old file. I captured this file way back in, I think, 2013. We can look at the top of the information here, and 2003. So this this trace file is what, almost 15 years old. But here's the funny thing about trace files. Even though they're old and they contain old packets out there, they still have a lot of good information about what's going on. So we're going to dig down through this trace and we're going to take a look at a few key things. And I'm going to window that again because I want to be able to get in here. I want to show you an important feature of Wireshark. And I'm going to use this quite a bit, and we're really going to focus in on that. If we come down here into the bottom corner, and I draw a little circle right around there. I don't want to make sure that that's not on top of me there. But you see it says Profile TCP. I'll just move over there a little bit so you can get a better look at that. And that Profile TCP tells us what profile that we're using within Wireshark. And profiles are a real important one because profiles allow us to save our filters, our columns, our color rules, things like that to a profile. And then I can go back and I can use that profile over and over again. So one of the keys to using Wireshark successfully is configuring it for your environment, configuring it for the way that you want to go in and analyze packets. So we're going to escape out of there. So if I came up and I went to Edit and I went in here to Configuration Profiles, this is going to show some of the profiles I have. So I'm going to add a new profile. And we're going to call this live stream. Okay, I'm going to click OK. Now, when I create that live stream profile, what we notice is, again, down there in that lower corner, we see that it says live stream. So there's our new profile that we just created. And these profiles are saved out on the disk. So we can go out and we can dig these up pretty easily. Someone said my volume seems a little bit low, so we're going to crank the volume up there just a little bit and make sure that everybody can hear me okay. In fact, I'll just bump that up a little. Well, I don't want it clipping off too much, but we'll give that a shot right there and see if that helps. Okay. So in this case, we're going to come in, we're going to hit escape on, let me hit escape on here. Okay. And hopefully the volume's a little bit better now. I turned up the microphone a bit. But in this case, what we're going to do is I'm going to come in here and we've created this new stream. Now when I create that new stream, I've got my packets in there, I've got my colorization rules. Now these colorization rules are going to colorize the packets based on what's going on in there. Now, you know, it's one of those things where it's up to you, do you like the colorization? Do you not like the colorization? For today, we are going to go in and I am going to turn off the packet colorization. So what this does, this takes off those colorization rules in there, and we see that we're getting the packets. So now I want to create the filter that I use the most. And this filter is going to help me identify when I have bad TCP frames. Because oftentimes people complain, I can't connect to something, I can't, the network's running slow, I've got a problem. So what I'm going to do is I'm going to come up here and I'm going to type in tcp.analysis. And this is important to note as well, and I lost it when I hit that key, is that as we're typing it in, it's showing us the available filters that we can put in here. So I'm going to go into tcp.analysis.flags. Now this will be set anytime that Wireshark detects that there's a problem with TCP. So in this case, by setting tcp.analysis.flags, I'm going to look for any bad TCP frames. Now I can click this little blue arrow right here, and that's going to apply that filter. Okay. So now this is showing me any case where I've seen my tcp.analysis flags. And if we drill in, we see, what have we seen in here? Well, I'm seeing some Tcp retransmissions. So these retransmissions could be an indicator that I'm having trouble connecting out there to a website or to a server that I'm trying to get to. So if I scroll down, one of the ones I'm really interested in is these TCP SYN frames right here. Now, some of these may be not really an issue, because if I'm trying to connect to a resource that doesn't exist, maybe that's not a big problem. But right here, I see a TCP retransmission where I'm trying to connect to port 80 on a website out here. That is an issue. So this brings us to the next piece that's really important when we're going in and setting up our profiles and starting to get in and decode packets. And that is saving these filters. So what I'm going to do is I'm going to come in here and I'm going to click on this little plus symbol right up here at the top of the screen. And we'll just drill in a little bit. I'm going to draw a circle around it. So I really want you to pay attention to that. And that little plus right there is an indicator where we can add our display filter. So I'm going to click on that plus. And it says right here, label, apply this filter, filter, tcp.analysis.flags. So I'll come in and I'm going to say bad TCP. And I'm going to click OK. Now when I do that, it adds this filter right up here at the top. So if I go up and I clear out that filter, we're seeing all of our frames. If I want to go back in and I want to see just the bad TCP frames, I can now come in here and click on bad TCP. And that will show me those frames, and I've now created that filter. So what I find is that I end up going in and creating these types of filters over and over again. And those filters are unique to that profile, to that type of traffic that I want to go in and monitor. So by doing that, it allows me to quickly filter in on those packets that I really care about. Okay? So now let's go back down here. And we see that I've got some TCP SYN packets right here where I'm seeing retransmissions. So what I'm going to do is I can click on that frame. Now the next thing that I'm going to do is we're going to go in and I want to drill in on just that one TCP conversation. Because what's one of the problems that we run into when we're going out and we're analyzing traffic using Wireshark? We're looking at too much traffic at one time. We're trying to take a look at too big a picture. So what we want to do is we want to go in and we want to drill in on just those packets that are having problems. So what I'm going to do is I'm going to come into this frame right here. I'm going to right click and I am going to go to follow TCP stream. Now when I do that, it creates a filter on just that TCP conversation. It then comes in and it tells us, okay, you know, we're going to go out, we're going to get this GIF image right here. We're going to say, you know, use local copy. That's fine. There's sometimes when I'm interested in the text that's in there. But in this case, I'm going to hit close. And I'm more interested in what's going on with my packets right here. So the next piece that I'm going to take a look at is my timing. And right now, this is showing me typically the time since the beginning of the trace file. So I'm going to come up to View, and I'm going to go into Time Display Format. And I'm going to change that since seconds since previous displayed packet. I click OK. Now, what this does is this shows me the traffic for this one TCP conversation from beginning to end. And it shows me the time between each one of those packets. I can tell you in my career of going out and doing network analysis, not once has anybody ever contacted me and said, Mike, my network is running too fast. In every case, somebody has contacted me and said, Mike, my network is running too slow. So if we have a network that is running slow, then what we want to look at is we want to look at the delta time, this time between each one of these packets. And in this case, we send that first TCP frame right here at frame 132. We then are waiting for a TCP SYN acknowledgement. This lets us know that that frame made it to the device at the other end. Here, we see we didn't get that SYN acknowledgement. So what do? Well, TCP is going to retransmit that SYN frame. So in this example, we see that that SYN is retransmitted 2.92 seconds later. That is a 3-second delay that we see out there between the time that we sent that first SYN packet and when we got the response back. So that 3 seconds is a ridiculous amount of time when it comes to going across the internet. Now I send that, and let's escape out, and we'll zoom back in again. And when I resend that SYN, here we get our SYN acknowledgement back. And we get that SYN acknowledgement back 31 milliseconds later. That's the round trip time between us and that server. So what should have taken 31 milliseconds ended up taking us over 3 seconds. Okay? So in that case, you know, that turns into an issue because we're waiting. And if we went back and we took a look at what was happening out there as far as our, let me just adjust that a little bit. If we take a look at what was happening out there as far as that traffic going across, what we found was in this particular example, and we're going to, let me do this again. I'm going to right click, I'm going to do follow TCP stream again. And I want you to take a look at this text, because what's happening here? Well, in this case, I'm going out and I'm going out to get this image. And the server that I'm communicating with came back and said, use local copy. So the copy I had cached on my machine was already the right copy. I didn't even need to get anything off of the network, but I ended up going all the way out there to have to find out that that copy was still good, and it took me 3 seconds to find that out. This is an indication of packet loss across our network. I sent that packet out, I didn't get a response back. So from a troubleshooting standpoint, we then have to start digging into where is that packet loss occurring. So this is where we need to capture in multiple locations throughout our network. And by doing that, we can take and compare those captures and find out where along the path are we losing those packets. Okay? So let's come in and we're going to close this particular trace file. So honestly, this trace file was one that I didn't even really put a whole lot of effort into going out and capturing. I was working late one night. I decided to capture this trace of going out to the Department of Transportation website, and this is what I got. So let's go in, and I'm going to open up a trace. And I'm going to open up slow HTTP GET. Now, slow HTTP GET, let's clear that filter right there. This is an example of where we're going to go out and we're going to get an image, and we're going to find out how long does it take to get a response back. So in this case, here I've got this HTTP GET right here. And I'm going to do my follow TCP stream on that. Okay. Now, what I want to show you is, kind of the nuances of looking at this trace file. And this is what it is really all about, is going in and taking a look at all of those little details in there about the trace and what tells us, what's an issue, what's not an issue, etc. So in this particular trace, what we're seeing is that we send this TCP SYN frame right here in frame number 4. So I send out that SYN, and I just cannot overemphasize how important it is that we go in and do things like follow TCP stream. Why? Because that helps us zoom in to just those packets that we're interested in for this particular stream. I then find that I get my TCP SYN acknowledgement back in 134 milliseconds. So anytime I'm analyzing a trace file, one of the first things that I'll do is I'll go in and I'll start trying to get a mental image of what is my round trip time. How far away is this server from me? So once I do that, and I know about how far away that server is, then I can take a look at the rest of the trace and get an idea, does this look like something I expect? Okay, so in this case, I send my TCP or my HTTP GET right there. Give me your web page. I want to see the front page of this website. Now, I get an acknowledgement back right here at 125 milliseconds. Okay, so I get this ACK back. Now we could start digging through these frames, and I can show you that if I send this HTTP GET right here, and let's start digging into the detail section of our packet. And I'm going to go into my transmission control protocol header. And what we find is this is TCP sequence number 1. Okay, right there. TCP sequence number 1. That's that HTTP GET. And I sent 348 bytes of data in that frame. Now, how do I let you know that I got a TCP data segment? I send you back an acknowledgement that is equal to the sequence number plus the number of bytes I received. So if I send you sequence number 1, and I go in and I send back, I send that many bytes of data, 348 bytes of data, I would expect an acknowledgement of 349. So let's see if we see that. Well, right there, ACK 349. And in fact, in our frame, right here, it tells us that our next sequence number is 349. That's what we expect the next sequence number to be. So how about that? Right up here, 125 milliseconds later, I get an acknowledgement back. If I know that my round trip time between myself and the device out there at the far end is about 134 milliseconds, and I get an ACK back in 1/8 of a second, right? 125. That's consistent. That's about what I would expect for an acknowledgement to come back. So if that's the case, and I get that acknowledgement coming back in there in that period of time, then that tells me the packet got all the way to the other end, and I got an acknowledgement back. That server got the packet. Let's look at the next frame. The next frame shows us 4.85 seconds. That is how long it took us. I'm just going to zoom in again so it's easier to see. Right down here in our bytes, we see that that is where we got our HTTP OK. That is where we got our response back from the server with the web page. But that response took us 4.85 seconds. So in this case, if we said, is this a problem with the network or is this a problem with the server? Well, the server got the packet in a quarter, or in 1/8 of a second, 125 milliseconds. We got the ACK back. It told us I got the packet, but it took 4.8 seconds to get a response back. So in that case, it's not a problem with the network. It's a problem with the server. This is like getting a return receipt when we send certified mail. So by being able to go in and start taking a look at these trace files and seeing what's going on in there with the packets, it is a way that we can start getting a feel of what's going on with our network. Okay? So I could come into this trace, I could say, are there any problems? Well, I could click on bad TCP, and we see that we've got a dupack in here. We've got a spurious retransmission, which can sometimes be caused by a retransmission. Well, let's see. Let's filter in on that. We're going to follow that TCP stream. And what I like about Wireshark, it holds position for me here. So we see that, we saw a retransmission right there. So we could take a look at our sequence number. We see that that sequence number 14419, and we see that there's sequence number 14419 up there. Now what can happen sometimes is we can run into a situation where our device right here thought that the packet was lost. It waited 148 milliseconds right there before it got an acknowledgement, and it had sent this retransmission out. So in this case, this could be an example of where we retransmit, or the other end retransmitted that because it thought that we hadn't gotten it, and it took it so long to get an acknowledgement back, it retransmitted that packet. Okay. We could run into places right here where we have a duplicate acknowledgement that is a result of that spurious retransmission. So in that case, probably not really a problem. But this gives us a way that we could go in by taking a look at when did we receive that acknowledgement. So I always look when I'm analyzing packets, did I get an ACK? If I got an ACK, then I know the device at the other end has it. If I didn't get an acknowledgement to the packet, then the packet never made it there, and I need to start taking a look at where that packet potentially could have gotten lost. Okay. So there's an example of taking a look at a trace where, overall, traffic was good, no packet loss. But we had a case where we had a slow server on the other end. Okay, so I'm going to clear that filter out. We're going to open another trace. In this particular session, I want to go through a few different traces and take a look at some things that we might see out there. And this is a real good one. This is bad DNS. So let's go ahead and take a look at bad DNS. Now, bad DNS was a case where we were at a hotel down in Florida. We were trying to do a class and it just wasn't working. Every time we tried to go out to the internet, we'd have trouble getting to the internet. So let's go in and take a look and see what we have going on with our packets. So right up here, I start out and I send a DNS query right there for google.com. And I get a response back. And if we drill into that response right there, it shows us on this line the IP address that's being returned for google.com, and that's 0.0.0.1. Now, the probability of Google having the IP address of 1 is very, very unlikely. So what that tells me is something's wrong. This could explain why I'm having trouble getting out to the internet. I'm getting a bad address. Now, if I look at what server's sending my response, I see it's 4.2.2.2. Now I could come up here and I could say view, and I could say name resolution. Now normally we turn off network name resolution because if you're doing a big capture, this can result in a lot of DNS queries going out. So what I'm going to do is I'm going to come in and I'm going to hit resolve the addresses. I'm going to reload my trace right here. Okay, so we can see if it's going to resolve that network address right there. Okay, so 4.2.2.2, that is a pretty major DNS server to be returning 0.0.0.1. So here's the first thing I look at when I see a case where I'm getting information coming back that just doesn't look right. I'm going to come into my IP header and I'm going to look at my time to live. Where did this come from? So in this case, we see that our time to live is 62. Now our time to live normally starts at 255, 128, 64, sometimes 60, 32. Now people can adjust this to whatever they want, but this is an example of where we would expect that it would start out at 255, 128, 64. Now, if it started out at 255, that means that I would have gone through about 193 hops to get to this device. That doesn't sound reasonable. If it started out at 128, that means that I would have gone through approximately 66 hops. That still doesn't sound right. So the other alternative is 2 hops. Now that means that the DNS server was probably in the same hotel I was, which is very improbable. So this is an example of where that number tells us that something could be intercepting our packets and responding to us with improper information. Okay? Now let's come down here and I see that in frame number 4, I get what appears to be a more reasonable answer. In fact, if we expand out our DNS section and we come in and we take a look at our records in here, we get a list of IP addresses that seem to make sense. Okay. This is where we have to go and we have to put a little thought into it. We have to say, does this make sense, what we're seeing? And in this case, what we're seeing is addresses that seem to make sense. So let's go back up and take a look at what our time to live looked like for that particular frame. Was it 62? No, it was not 62. It was 254. 254 makes sense. 254 says, I came through about 10 hops. Okay. That tells me that I'm probably talking to the real 4.2.2.2. So let me show you this. And this is something that when it comes to going in and using Wireshark makes it much more usable. And that is that time to live field. I could go into each packet and I could take a look and see what that time to live looked like. Or I can go in and take that time to live and make it a column. So I'm going to right click on time to live. And I'm going to say apply as column. So now what we see is that we now have our time to live up here as a column. And we find that, you know, the ones that are originating from our machines have a time to live of 128. We see that right here, this one that worked okay, where we got reasonable addresses back, has a time to live of 245. We see that this one right here has a time to live of 248. Those are reasonable numbers. Those are numbers that we would expect out of there. But we find right here that where we get a response of 0.0.0.1, that has a time to live of 62. Now, what we ended up finding out in this particular situation was that the network that we were connected to had a system in there, like a lot of hotels do, for intercepting our packets and making us pay to connect to the internet. This system was broken. So periodically, instead of putting in the IP address of the gateway at the hotel, it would put in 0.0.0.1. Now, if we had somebody that had put a device in line that was trying to redirect us to a site and collect our credentials, trying to collect our login information, we would see that the time to live would come back. Rarely do we see that these systems will go in and go so far as to adjust the time to live to make it look like that server's further away. So this is where we can use a tool like Wireshark to make sure that the packets are coming from the source we expect them to. If that time to live all of a sudden becomes much shorter than what we would expect, that would be a clear indication that that packet is originating from somewhere other than where we would expect it to originate. Okay, so, you know, just some little things out there. You know, we've taken a look at, I can use my profile, and what we find is that now that column, that time to live column, is saved in that profile. So if I go back and open the live stream profile again, that column's going to be there. The columns are going to be there in that order. That bad TCP filter is going to be in there. So this helps me drill in to those things just a little bit faster. Now, let's go ahead and we're going to take a look at another one in here. And that is, I'm going to come in and I'm going to say File Open. And what I've got, I used a WAN emulator to allow me to impair some network connections. And with this WAN emulator, I said, you know what? What if we run traffic at a variety of different TCP window sizes and a variety of different loss rates? So in this case, we're going to grab, this is a real nice one in here, we're going to grab this conversation. This is a 100 megabit per second wide area network connection with 40 millisecond round trip time and no packet loss and a 64K window. And we're going to click on sender side. So in this case, what I did was I did an iPerf test. And I ran traffic through the network and I captured it. So we're going to scroll down. And for this particular demonstration, what I want to do is I want to grab a packet that has bytes, right? So we have 60 bytes. This is an ACK. I want to get data where I'm actually sending the data across. So I'm going to grab one that says 1514 right there. And I'm going to come up to statistics. And I'm going to go to TCP stream graphs. And I'm going to go to my Stevens graph. Now what Wireshark is going to do is it's going to go through this trace and it is going to graph out TCP sequence number over time. So this is a beautiful graph because what we're seeing in this graph is we are seeing where we are graphing out that TCP sequence number over time. And right down here at the bottom, this is a beautiful picture of Tcp Slow-Start. This is where TCP is sending frames out and it's slowly sending more and more frames out onto the wire to see how many can we have out there at a time. And the fact that this line, I'm just using the roller on my mouse to zoom in and out, but as we zoom out, we can see this is a beautifully straight line. This is exactly what we want to see for a file transfer. This tells us that we're moving data through there and that is going great. So now I'm going to hit close. And I'm going to come up here and I'm going to go to my statistics and I'm going to say let's see. I want to see capture file properties. Now, when I look at capture file properties, this shows me for my captured and my displayed what my average bits per second were. So I was getting about 11 megabits per second out of this connection. Now in a future session, we could talk about things like bandwidth delay product and why is it I'm not getting 100 meg when it's a 100 meg circuit. That's for a different day. But by using my packet or my capture file properties, I can come in and start getting an idea of what type of bandwidth am I getting. Now, let's go in and we're going to close that and we're going to open a different trace file. In this case, let's come up here. We're going to open this 45 megabits per second with 2% packet loss. We're going to open that from the sender side. I'm going to come down, I'm going to grab one of those 15, 14 byte packets, I go to statistics, and I'm going to look at my Stevens graph. Oh, that's horrible. Look at this thing. That doesn't look anything like that other graph. And why doesn't it look anything like that other graph? Because we have packet loss going on. And that packet loss is impacting our ability to move those bytes across the wire. Now let's drill in. And this is one of the things that is an indicator of packet loss right here. And each one of these dots represents a data segment that we sent. And in this case, we see dots that are southeast of our line. So here we've gone in and we sent data, boom, 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 boom. Then we waited for an acknowledgement. We sent some more data. But if we get up to here, we see that we've got these dots that are southeast of our data line right there. Those lines that are southeast right there are an indicator that we are retransmitting segments. And when we look at what happens after we retransmit those segments, we go back into Slow-Start. And then we see some retransmission. And then we go back into Slow-Start again. And so if we came up here, let's hit close, and we look at our capture file properties, our average bits per second, 742 kilobits per second. That is horrible. So this is an indication that we're seeing packet loss out there. We would want to go in, find out the cause of that packet loss, and eliminate that. That is having a significant impact on our ability to move those packets across the wire. So this is an example of how we can use tools like the TCP stream analysis to illustrate what's going on with our TCP frames. It's very easy to show somebody those two graphs and say this is when things are working good and this is when things are working poorly. So by doing that, we can say, we can start showing this is what the impact of packet loss looks like on the traffic that we're sending across there. Okay. Let's see. Let's open another one. We're just going to go through a few more little traces here. Oh, I know. Let's see. Go back up there. Oh, let's see. Let's go back into .cam. And actually, let's just do this. We've got, I'm gonna close this. I'm gonna open up my web browser right here. So what I've done, and this is also, we're not gonna have time to get into this today, but what I've done is I've gone in and I have set up a PC. And this PC is running Linux, and it is doing capture to disk. So it's been set up so that every time it starts up, it just starts capturing packets to disk. And if I came in and I looked at my capture files, what we would find is I've got this ring buffer out here. And we'll do another session on how we can go in and set up a ring buffer. But what we find with this ring buffer is that this is taking and writing 50 meg files out there to disk. And every time that file fills up, it writes another one, it writes another one, it writes another one. So I am capturing all the time on my WAN link. So if I came out here and I said, you know what, let's take a look at 1016 on, well, let's see, we'll do, we see some traffic. We're going to take a look at this trace from Wednesday. So the great thing with this is this allows me to go back in time. And by capturing to a ring buffer, we are capturing all the time. So when someone calls up and they said, you know, yesterday things seemed kind of slow at this time, we have a way we can go back and take a look at that. So now what I'm going to do is I'm going to come in and I'm going to open that trace file. So I just created a little web page so I could pull those trace files down off my machine. So now we're going to open this 50 meg trace file. And we're going to take a quick look at DNS. And I'm going to show you, a couple things that we can do in here when it comes to DNS. Okay, so we open the trace file. And first thing I'm going to do is I'm going to come up to the top, I'm going to type in DNS. And I'm going to apply that filter right there. So this is going to go through my trace file, and it is going to filter that trace out looking just for DNS frames. Now that takes a while because this is 50 meg worth of trace, and I got my machine doing lots of other things like producing this video. So we will let that come back, and there's all of our DNS traffic. So what we see is if we look down at the bottom, that DNS traffic was 2,025 frames, and it made up 2.6% of our overall packets. So what I want to do is, instead of having to go back and dig through all of those packets again every time to take a look at the DNS traffic, what I'm going to do is I'm going to come in here and I'm going to say File, and I'm going to say Export Specified Packets. We cannot do a Save As. If you do a Save As, it will save everything. What we need to do is we need to come in and say Export Specified Packets. So right down here, we see it says Displayed. And so what we'll do is, let's see, we're going to come in and I'll go ahead and say, we're going to call this DNS only. And I'm going to hit Save. So now it's going to save just those packets. So we're going to close this trace file, that big trace file. I'm going to say File Open. I'm going to open DNS only. So now in this case, what I've done is I've opened just those DNS frames. And see how much faster that opened? There's no sense fighting with that trace file going through hundreds of thousands of frames when we're only concerned with these 2,000. I'm going to get rid of this column because I'm going to show you how to add that here. So what I'm going to do is I'm going to say there's my time to live right there. And we're going to go in and I'm going to say Edit, Configuration Profiles. And we're going to create a new one. We're going to add one. We're going to call it DNS. Say OK. So now we've got our DNS. For this one, I'm going to go in and turn off my packet colorization. And I'm going to come in here and I want to see how long did it take to get replies to my DNS queries. So if I were to come in and click on a DNS response, and I expanded domain name system. So if I came into my details section right here, and I expand the DNS portion of that, what I find is right here, I've got time. That time shows that if the request was in frame 12 and the response was in frame 14, it took 25 milliseconds to get a response to that DNS query. So I can right-click on time and I can say Apply as column. So now what we see is we have a column right here that is showing us all of our DNS response times. So if we have a slow DNS server, this can cause everything to be slow. So if I want to quickly find my slowest DNS queries, there's a few things I could do. One is I could come up here to my filter and I could say DNS.time. How did I know that there was a time? Well, because here are all of the different things I can filter on for DNS. And right there is DNS time. Also, let's clear that out. If I click on this frame right here, if we go down to the bottom of the screen, it shows us the name of that field right there, DNS time. So what I can do is I could come up and say DNS.time greater than 1. This would show me any case where my DNS response time was greater than a second. Okay, that's good. We didn't see any of those. How about DNS time greater than 0.1? This is every case where it took me more than 100 milliseconds to get a response to my DNS request. So we find that, yeah, we've got some approaching 190 up there. So part of it is, what's our expectation? If we're expecting that we're going to get a response faster than that, then yes, we would want to get in and find out why that's slow. We could also come in here and find out which servers tend to be the slowest. Okay. So if we came over here, we see that 184 tends to be pretty slow. 95 tends to be slow. Here's one of the things I found with a lot of organizations. They're given a list of DNS servers from their ISP, and they typically use those DNS servers in the order in which they were given those IP addresses from their ISP. Do you think everybody does that? Yes, they do. So that means that everybody is using that DNS server that's at the top of the list first. Then they're using the second one. So oftentimes what I'll do is I'll flip them over. I'll use the last DNS server first. Why? Because that's the one that most people are least likely to use. There's tools like DNS Bench. And DNS Bench is a free little tool that will go out and measure the response time to DNS servers. So because we send so many DNS queries in this very relatively short trace on our WAN link, we sent at least 1,000 DNS queries. We want to make sure that those DNS queries are getting responded to in a timely manner. So it's by going in and taking a look at that, we can also see, are there particular DNS names that are taking longer to get a response? So in this case, I have now created this filter. So I could say, let's say that I define that anything over 150 milliseconds is excessive. So here are my excessive DNS queries as far as I'm concerned. So if we go back and we use that plus symbol again, I could say, label this, I'll call this slow DNS. Okay. So now, if we clear out all of our filters, and I were to come in and say, hey, do I have any what I consider to be slow DNS queries here? I click on slow DNS. Do you see how fast that is? When we want to go in and we want to be able to grab a quick picture of what's going on in our trace, I'm not having to type these filters in over and over again. In fact, if you share these profiles with others, so if I go to help and I go to about Wireshark and I go to folders, right here it tells me where do I store things like my my configurations, right? So I could go in and we could look in these directories, and it's going to show me where I'm storing these different files, okay? You can share those profiles with others, and you can say, here's this profile. So the first thing I want you to do when you're looking at DNS is I want you to click on slow DNS. We could say, let's just go in, we could say right here are flags. And we could look at opcode. So we could say there's a query, so there's a response. We could say error code. So if I came up here and I cleared out that filter and I grabbed a response and I right click on error code and I say, this is another powerful one, apply as filter, or even better yet, prepare as filter. I'll say selected. So now if I say DNS flags our code, that's our return code, and I put a exclamation mark in front of that. Right here it says, show me any case where my DNS flags.return code is not equal to 0. Okay. Ooh, well, pretty much every one of my queries comes back with that. Okay, so that isn't very good. So now what I would do is I would clear that filter out. And this is where, you know, our trial and error in a lot of cases comes in building these filters. But now what I'd want to do is right here where it says message is a response. Well, that return code only means anything if the message is a response. So I'm going to come in, I'm going to right click on that, I'm going to say prepare as filter, selected. And then I'm going to say and then we'll say return code. We're going to right click on that, we're going to say prepare as filter, but this time we're going to say and not selected. Show me any case where it is a response code and it is not that. Now I've done something haywire. I put my and in there when I wasn't supposed to. So let's fix that. How did I know it was bad? Because it was red. Now it's green. I'm going to apply that. And this shows me any case where I got a return code that was an error. Now in this case, no such name. So these are cases where I went out and I did a lookup and I got a response back that said, that name doesn't exist. What if I don't care? I don't care if no such name is really even an issue. Well, we could go in and we could keep adding things. I could say, take this, prepare as filter, and say and selected. Well, we would say and not. So show me any case where it's a response. The return code's not equal to 0, but it's not name not found, or no such name. Okay, so what we find is that in this case, we don't have any DNS errors that end up in a situation where it is not, it's an error and it's not a no such name. So I could hit my plus over there and I could say DNS failed. We could put something like that in there. Okay. So what this does is this allows us to go in and start creating these filters and saving those. That gets saved with that profile. And I can always come down and it's back behind me. Let me move that out of the way there. If I ever click on that profile right there, it'll bring it up and show me all those different profiles I have available. Okay. So going through and taking a look at packets is one of those things that we get better with time. You got to capture them, you got to look at them. You have to start setting up filters and zooming into just those packets you're interested in. So some of the things I wanted to cover today, how can we use things like our little Netgear switch right here to tap in and monitor those packets. Okay, so I'm going to come over here. I'm going to put in that is the GS or Netgear GS105E. That's the switch I use. That thing runs about 32 bucks on Amazon right now. Great little tool for being able to go in and get in the path of the packets. You want to see how to set that up as a span device? Go out, check that out on my channel. There's a video on there. Okay. We've got the LinkedIn protocol analysis. Okay, I've got the LinkedIn Protocol Analysis and Troubleshooting group. Feel free to go out and check that out. We've got great information out there from a number of contributors on network troubleshooting, things like that. So I am going to continue to do these. It's a great way, doing them live like this is a great way to get me to record them and do that. What we'll do is the next one that we do, we will start where we're at here and we'll keep moving along and digging further in. But what I encourage you to do is go out, start capturing packets, start taking a look at what's going on. One of the keys, let me make myself a little bit bigger here just to emphasize this. One of the keys to successfully analyzing and troubleshooting packets is going out and doing it. If you don't go out and capture them, if you only wait until there's a time when there's a problem and you decide to start capturing them, then you're going to have trouble, because you're not going to know how to use the tools, you're not going to have your filters built, and you're not going to be familiar with how those protocols go back and forth. So I'd like to thank everyone for joining on for the session today. We will do more of these. We'll keep going through and taking a look at how to decode packets with Wireshark, how to go in and do troubleshooting. So I'd like to thank everyone for joining. This is recorded and it's going to be out there so that if you want to go back and take a look at it later on, it'll be available for you. So thanks for joining me, and I hope to see you in a future session.